Should be working now. All right, someone keep an eye on this. Last time I did it, it stopped recording. So just make sure this little icon's there in the whole presentation. Someone can have a volunteer for that? Just kidding. All right. Okay, so today we are talking about the front-end space. I've kind of subtitled this presentation, "Oh, what a tangled web we weave," because oh, what a tangled web the front end is. So the presentation goals today, I want you to come away with an understanding of the concerns of the front end. I want you to have an understanding of the problem space and all of the problem spaces that we encounter with the front end. And we're going to be looking at some of the building blocks, some of the blocks that solve those problems. And then I want you to have an understanding of the building blocks that we have in the React starter and why we chose those pieces. So I do want to state that the React starter does address the concerns that we're going to be talking about today. But I want to kind of take a step back from the starter and really just look at the problem space itself and what needs to be done there. Okay. So if you remember previously on Donuts.js, we had Mike Jasper give us a presentation about the front-end space here at ICS and kind of a history of that. And he presented on how there's a wide range of different types of solutions that we're trying to come up with, different things. We have all the way from public content apps to internal apps, and they all have kind of a different range of concerns. There's things that some of them are concerned about that others aren't. And the Stack team, we've been trying to look at this and try to come up with solutions to solve all of these problems. Whereas in the past, we've kind of solved one area of the problem very well and not others as well, right? So we're trying to come up with solutions that solve the problem more wholly. So what are some of the requirements? What are some of the holy? Yeah, both. Holistically, but also holy. It's also both. Yeah. So just real quickly, there's a huge range. Here's kind of an illustration of the huge spectrum of problems that we're looking at. You know, we're worried about support. We're worried about being able to develop really quickly and also be able to maintain the solutions that we have. And you know, there's a lot of concerns here. My favorite is make it fun. You know, we want it to be fun for people to do this, right? And all these problems kind of grow from the fact that we don't have much control over the platform, specifically the client's platform, right? The browser is something that we don't have much control over what it is, right? And that creates a lot of problems. That creates a lot of complexities, and there's all these challenges and problems that we're worried about. And what can we do? What approaches can we do to try and solve all of these problems that we have, right? One thing we could try to do is use tools that try to abstract these problems, right? Where the tool tries to solve the problem, and we can live on this little abstraction layer, right? We could try to do that. Another approach is we could try to take the problems and modularize them, break them down into smaller problems and solve those. And then take those solutions and put them together and have that be our overall solution, right? So there's some different pros to these two different routes that we can go. So with modular is more adaptive. We'll be able to be more adaptive to the problems that we currently have, the different range of the problems that there are, and the solutions that we come up with will be easier to maintain, right? And will solve a greater range of the problem. With the monolith, there'll be less fatigue. We will be able to just have this solution and not have to worry about it anymore. And it'll be a very well-defined path, right? But it also solves a smaller set of problems, right? So today we're going to be diving into the modular approach. We're going to be really diving into, let's break this problem up into small pieces and try and solve them individually and find solutions for those individual pieces. So here's a little, just kind of, I guess, my representation of the different ways that we can break up the problem space of the web. And we're going to be diving into each one of these a little more fully, so don't worry about that too much. So we've got style, UI rendering, routing, state, the build process, and the overall engine that we're running on, right? These are kind of the main core problem spaces that we have when working with the front end. Okay, so let's go ahead and dive into these. So runtime engine. So we're talking about the actual server that we're delivering our application from and the browser. So what are some of the problems here? What's some of the painful parts here? That's not a rhetorical question. I can wait longer than you can.
Lack of compatibility.
Lack of compatibility. What do you mean by that exactly?
Certain browsers and certain servers don't support certain aspects of the language.
Yep. What else?
You have multiple browsers that all have their own issues.
Right, all the browsers have their own issues, their own problems. Yeah. Okay, so part of the problem is that it is two things, right? It's a two-headed monster that we have to manage, right? We've got the server that's loading up our application, and we have the browser. So what are some problems there that we have? Derek?
I would think, like, who's responsible for what?
Mm-hmm.
Like, it's not always a clear understanding of like what part's going to do routing, or what part is going to do who's going to render where, and it's not, it varies on problem requirements in space, but it's not. There's not a simple answer for that question.
Right. So for recording, it's hard to know what does what. What's responsible for doing what parts of the problem. What should do routing? What should do this? What should do that? Is there any other things? Any other points I want to make? Oh, yep.
Mismatching resources.
Mismatching resources?
Yes.
Could you give an example of that?
You're running on a phone.
Okay.
You've got much more limited resources than the server does.
Right. So the actual devices and things that we're going to be running on are going to be varying, right? So we have a lack of control of the actual runtime environment of our application. We can control the server, we can control that, but we don't have as much control over what our code that we send down the pipe is actually going to be run on. We don't have any control over that, right?
Our app could end up being basically two separate code bases that are both required to fulfill the one app.
So we could have two completely different code bases that are both trying to solve the same problem, right? Where we have a whole application on the server and a whole application that we deliver down the pipe, and we'd have to maintain both of them. Yeah.
One can be very fast and the other can be very slow.
Yeah, there's varying speeds there. Yeah. So here's some of the things that I've got down. So we've covered these pretty much. So we have to solve every problem in both spaces, right? We'd have to do it twice, right? Some of the things that we need to be concerned about is SEO, right? Search engines. We need to be worried about that. That's kind of why we need things to be running in both places, right? We want to be able to link into something and have the server be able to respond to it the same way that the application would respond to it when it's on the client itself. And so it's a big problem, right? And so what are some of the things that we can do? Oh, what the?
Ding, ding.
How do I get a? That's right. So go away. Oh, it's because I've got Outlook open. Why do I have Outlook? Okay, there we go. It's dead. Oh, and I'm mute. There we go. Thank you. I'm not listening to people. All right, so we're muted now. Okay, so back to the presentation. All right, so we'd have to have two applications in both places, right? We'd have an application that we send in a wire. We have an application that that runs purely on the server, right? That's one thing that we could do. We could try to write an application that can actually run in both places, so that we have one code base that runs in both places. And there's some complexities there. There's some challenges that we'd have to overcome there. We could just have the client do everything and have the server, when someone hits some deep thing in the server, we're just gonna, send the whole application down and get the application figured out. Right? We could do that, right? Or we could go back to the 70s and have the server just do everything. No client, right?
You weren't even born then.
2007.
Right. Okay. So what have we done? So we've looked at Node. We've decided that Node is the thing that we can do here. So we can't really control the browser. We can't just say nope. We're only going to have Chrome, right? We can totally enforce our users only using Chrome, right? We can totally do that. No. So we can't control the server though. So no, we've chosen Node, and the reason why is because it is JavaScript. It can actually run JavaScript, and so it enables us to achieve that isomorphism that we need to solve a problem here, right? Okay, so we've looked a little bit. We've kind of explored the problem space of the runtime engine and the actual runtime engine that we have in the front end space, and we've talked about how the browser and Node are the things that we're going to be using. We don't really have much choice when it comes to the browser, and that's okay. All right, so let's go ahead and move on. So UI rendering. So UI rendering, this is about actually creating the UI. What's going to actually create the UI? So what are some of the pain points here? What's hard about this problem? Browser incompatibilities again. Yeah.
What you render to, server side, you render to a string if you're using templating there.
Mm-hmm.
Client side, you render either to also a string or a set of DOM operations, depending on what templating language you're using.
So on the server, you either just you render a string, or where on the client side, it might be a string, but it might also be some other things.
Speed.
Speed? What, can you expound on that a little?
Sure. There's a lot of different areas where speed's an issue. Size, network, are probably the two biggest things.
Or speed when you're on rendering when you're talking about large data sets.
So trying to render large data sets, it can be slow depending upon what solution you're using. Okay. Yeah?
Even how you render over time.
Rendering over time over the lifespan of the application when it's running.
Right.
Yeah.
Re-rendering, essentially.
Being able to re-render. And so, because things are dynamic, right? Our application needs to be dynamic and respond to what the user's doing. And so what is going to be rendered on the UI is going to be changing over time. Okay. So the basic problem space here is just building user interface, right? We're building user interface based on state. That is a very quick summary of what the problem is that we're trying to achieve, and then rendering that to the DOM. And now we've talked about some of the things here. So state is constantly changing, right? The UI needs to try and keep up with all the things that are happening, right? All of the different changes and things that are happening. And we also need to be concerned about this two-headed monster again, right? It's still not gone away because we need to be rendering this server side as well as client side, right? Either that or we're going to have that two application monster, right? Which is a much bigger problem than just the two-headed monster itself. Okay, so what are some things that we can do? So there's some things that we've looked at. We've looked at Riot, React. We've looked at Preact. We've used handlebars in the past. That's been used in many different places. And here at ICS, we've even had our own internal frameworks that have been developed and created. We've also used, am I too loud? Oh, okay, sorry. Thank you. We've also looked at Vue. So what have we chosen? What has the stat team, what could possibly be the thing that we've used? Okay, so it shouldn't be too much of a surprise. Who is surprised by that? By React? That's where you needed the crickets. It's all right. So React, we've chosen React. That's been kind of known. I don't think that's a surprise to anybody. So React, so why it? Well, it has a simple mental model. That is one thing that most people have said about it. And it's also, I'm still echoing, aren't I? I'm still feedbacking.
Volume down on the controls.
I can't really tell that I am. This is probably good now, right?
Pull the mic back towards you.
Okay. So let me get back into this. Okay. So React also has a strong composition model. It's been said about it that it's one of the best composition, being able to take different things that you've built and compose them together into a single view, a single template, or whatever you want to call it. It has one of the best models for actually doing that and achieving it. It's very painless and simple, right? One thing that we definitely appreciate about it is it favors using native tools, native solutions, right? It looks to use ES6 syntax and those solutions as opposed to trying to create its own solution, right? And it enables you to do that. It really points you to use the standard and use the spec, right? Also, it's very easy to have it actually be rendered both client side and server side, right? And it's fun. How many people here have used React, have written any amount of React? How many of you thought it was fun? How many people enjoyed writing React? Anyone that didn't? Has there been anyone that's used React and just thought it was terrible? Not a single hand. Literally not a single hand. Except for, no, Gibby almost raised his hand. Okay, so we've looked at the UI rendering problem space a little bit, and we've seen how React solves this particular problem space and fits well in this area. So let's go ahead and move on. Unless there's any questions. Anything? No? Okay. So routing. So here we're talking about actually routing from a particular route or URL or whatever it might be to an actual view. So what are some of the problems here? What's painful about trying to route when you're creating routes or anything like that? What's the challenges? What's the problem?
Not breaking the back button can be hard.
Not breaking the back button. So browser history, just maintaining the browser history itself.
Getting your app to be in the state that you want it to be with the URL.
So just achieving the problem of
Right.
getting the application. We want this URL to go to this view.
Well, because we have all these divs and stuff that are changing, and the URL doesn't always change.
So sometimes we're just changing the look and feel of things, and so actually updating the URL itself. So being able to tie it back into and update the history. So it's kind of a two-way thing here. We need the application to respond to this is where we're at, but we also need the application to be able to say, hey, tell the browser this is where we are now, right? So it's a two-way street there. Okay, so right, the problem space is mapping routes to views and also maintaining browser history, right? It is that two-way direction. The application needs to be able to communicate to the browser that this is where we are. This is update the history this way, and the browser, it also needs to be respond to the browser saying, hey, this is where we want. This is what resource we're wanting, right? Okay, so what are some things that we could do here? Well, some silly solutions that we could try to do is just have it one gigantic, huge switch statement that has every possible state that we could possibly have our application in, right? And just have a huge thing, right? If we're at home, okay, this is what we want to render. If we're here, then this is, and every single possible one, right? Every single user ID, right? Have a huge switch statement. That's totally maintainable, right? It's going to be easy. No. We could, again, go back to the good old days and just have static directories. We could just have the server have the static directories, because I mean that's kind of the ideal mental model. That's what it was based on, right? URLs, and so we could just do that. Just go back to that, right? There's totally no reason why we should have moved from there, right? Or are there reasons? Yeah, we should have moved. Okay. So then it's clear that we need some solutions here. We need something to help us manage this problem, right? So there's a few things that we've looked at. We've looked at React Router. We've looked at React Router Redux. Those are two different solutions. We've looked at Flow Router, Page.js, history.js. So there's several things out there that work in this problem space. And we've chosen React Router. So why? Why have we used this? Well, it has a good API for connecting to the HTML5 API. And its overall API is a very transparent and easy to understand. It's a very simple mental model, right? And it's a good abstraction layer over it, over this problem, right? And it's also very easy to compose your routes. It's easy to actually create the thing that's going to be mapping and creating these routes, right? Also, there's that keyword again. It's kind of an unhidden, undeclared theme of this presentation is isomorphism and achieving it. But it's isomorphic. So this solution can run both server side and client side, and it works just how you'd want it to be, right? Okay, so just a quick summary. We've looked at the routing problem space. We've looked at it, and we've seen how React Router is a good fit for this problem space. Okay, so let's go ahead and move on. So here we're actually hitting a pretty big section. This is a big problem space. I've actually got several sections just breaking down this individual problem space even more because it's such a monster. Okay, so state management. And so here we're specifically talking about the caching, storing, and generating of data, client side. We're talking purely about client side. So we're not necessarily talking about getting and setting stuff on your remote server or your remote service, right? Okay, so what is the problem here? What's painful about managing state in the client? Somebody that's not Jared. Not Jared. I can wait longer than you guys can. Anybody? Keeping things in sync. So keeping what specifically in sync? What parts? Keeping like the server and the back and the client in sync with each other.
Well, I think there's more of a problem keeping just the state in sync with what you view on the page.
Yeah, so just keeping things in sync with what you're rendering and what's being seen and the state. Just, I mean, it is a big problem. Just trying to keep your state, right? Okay. What else? Anything else? Do I need to give a definition? So state, I have a definition here. So state is an object that determines how components render and behaves. In other words, state is what allows you to create components that are dynamic and interactive, right? So it's purely talking about the data that represents this is how our application should look. This is what should be rendered. So are there any other thoughts, any other things that are painful about this? About state management? So I've got a few things here. So as we already said, just state management, even at its most basic level, is very complex. It's very hard to comprehend and understand, right? Especially when you have a state machine that allows you to just directly manipulate your state. And you also have asynchronous things happening that are going to be manipulating your state. It really is just a recipe for disaster. One article that I read compared it to Mentos and Coke. By themselves, they're good, right? But you put them together and you're going to have a huge mess on your hands, right? It's just going to be messy and crazy, right? So we talked about how keeping data synchronized even just within your application is difficult. And caching. Caching just period can be kind of a challenge. Just where do we do it? What should we cache? How are we going to actually cache it? How do we bust our cache? How do we, there's a lot of problems there, right? Okay, so what solutions are there? Well, some of the solutions that we've looked at Flux. We've looked at Redux, which is very similar to Flux. We've looked at MobX and Relay. These are some more solutions to the problem. So just quickly, how many people know what unidirectional data flow is? Could someone give me a definition without looking at the definition that I've provided? Nils? You totally, I saw you raise your hand. Okay, would someone be willing to give me a definition of unidirectional data flow? We've got a definition here. All data in the application follows the same life cycle pattern. Is there any?
I'll take a crack at it.
I understand, it's when you've got a loop where your actions, basically, whatever you're gonna have happen, it goes in one direction, so it always comes through in the same direction, as opposed to you have stuff going back and forth at the same simultaneously. It's maybe in a way, I don't want to compare it to synchronous versus async, but it's, you know what to expect when things are unidirectional as opposed to things going in and out at the same time.
Right. So we actually had a good presentation a while back. So if you go to Integration Point, Jared actually gave a really good presentation on this. I can't remember the exact title of the presentation. It's probably about like Redux or something. But there's a donuts out there that he describes the problem, and the problem of trying to manage state without this architecture and the benefits of it. And it's really good if you want to get into more of the details there. But unidirectional data flow is a great way to manage state. It is a stricter way to manage your state. It's a bit harder. Like there's more you have to do when defining what things are going to be changing in your state. But it's totally worth the effort, because it makes it so that you and anyone else that's going to be manipulating this application that you're defining, it makes it so much easier for them to manage what the state's doing, right? It makes it easier to reason about. Redux also, because it has you have your state in an immutable state, it enables you to do some really good debugging. And it also, because it's immutable, you're avoiding lots of problems. You're just eliminating an entire problem space because of it. Also, Redux plays very, very well with React. Okay, so the next section of state, so talking about state, is action orchestration. So this is taking a series of actions, a series of things that are going to happen, that all need to happen in this order, and getting them to work properly, right? So a quick example here would be, we've all had something where like the user's going to click on something and it's going to load some data. And while it's loading, we want to show a loading screen of some kind of loading bar or spinner or whatever it might be, just to indicate, hey, we're loading, right? And that request is going to be processing in the meantime. And once that request finishes, we then want to remove that loader and display the results of that request, whether it be the success and the actual data or some kind of error message of some kind or something. So that there's an order here that needs to happen. There's this orchestration that needs to happen. And there's some problems there. So what are some more problems? What's some more pain points when it comes to trying to orchestrating actions like this? Yes, Jared, you can raise your hand.
I think the complexity also comes when some of the things in the series are asynchronous, and the things that follow depend on the results of the thing before.
Right. So when you have maybe even multiple asynchronous things, that this asynchronous thing needs to happen, and then the result of that needs to go and tie into the asynchronous thing, this next asynchronous thing. Is that kind of what you're saying? Right. So there's the example that I gave was a very simple example of orchestration, but I mean it gets more complicated than that. How many people have done something more complicated when it comes to that than what I described? Anybody? A few people? Oh, come on, people. Gosh. All right. Is there any other pain points? Anything else any other voices that need to be heard?
So it's harder in the beginning. You try and design an application with a stable, consistent workflow. Those constraints make your initial implementation more difficult to build. But the payoff is that down the road, it makes it a whole lot easier to add new features and to add.
Right.
So you're moving your debt to the front of the project. That's a hard thing to bite off sometimes.
So having a strict upfront, this is how you make changes to your state, right. Setting that up ahead of time. Yes, it's a little more investment, a little more time, but the payout is huge later on. Right, I would agree with that. Okay, so So we've talked about this a little bit. So orchestrating state transitions, just all the different transitions that might need to happen and keeping them in order, you know, so that we don't sequence break anything, right? And having any number of things that are asynchronous in a chain of some kind, that can be very difficult to manage, right? You could easily find yourself in callback hell, right? How many people, who knows what callback hell is? How many people have experienced it firsthand, right? Did anyone like it? Did anyone think it was fun? No? It's very difficult, right? And so those are some of the problems here. Okay, so what solutions are there? Well, in Redux, we have a few things that we can use along with Redux. We can use Redux Thunk. We can just imperatively create these sequences all together. There's a few other solutions, Redux Saga, Redux Promise, right? How many people are familiar with promises? Yeah, most people are familiar with promises. Good. RxJS. Yeah, I should have added that too. So we've looked at Redux Thunk, and we've determined that that's a solution for helping us create this orchestration with our state. Redux does a good job of just maintaining state and has a good strict way of how you update and change your state, and it's a really good solution. Redux Thunk is a light solution to allow you to create this orchestration. So in essence, for those that are familiar with Redux, what it does under the scenes is it allows your action creators to be able to dispatch, instead of dispatch an actual action, it allows it to return a function that's going to receive dispatch, which then will be dispatching into your store, right? So anyone that's confused there, it's kind of a deeper inner workings of Redux and what it's doing. But essentially what this gets you is a really good separation of concerns within Redux itself. And we feel that it's a really good solution to that problem. Okay, so let's go ahead and go on to the next thing. So we've got managing data. So here we're actually talking about making requests and actually persisting data from the client to the server, to whatever remote server, whatever remote thing you're doing, your database or whatever it might be. And this data that the client might not necessarily own, right? So what are some pain points here? What's some problems? What's difficult about persisting data and getting data from an external source?
Well, many times when you get data from the external source, you need to sync it with the data that you already currently have.
Yep. You have to do some mapping.
Right.
Yeah, so sometimes the data is not necessarily in the form, the structure that you need it to be, and so you'll get it back and you need to do some stuff with it, right? And it might be the reverse too. You might then need to persist some data that you have on the client, and you need to make some changes to it before you actually try to persist it because the database expects it to be in a certain form or whatnot, right?
Just the fact that it's remote makes it complex, right? You don't really store things typically
Right.
in the browser.
You don't own the data.
You
The
don't own
client,
the
this client that we have, this whole application and everything and all its logic, it doesn't actually own the data, right? It doesn't have data. Right? It has to get it from something else.
That getting and setting is also asynchronous, and so there's some time constraints that you have to worry about there as well.
Right. So just the fact we've already kind of illustrated that asynchronous and data is a challenge. There's some real challenges there that we have to deal with, right?
Reconciling differences in remote data versus data that you have locally, and the repercussions of getting that right or wrong, like could go through your app forever.
Right.
If you reconcile data wrong at the beginning, then you're going to be in a broken state until you deal with it.
Oh, got another hand back here.
I think one of the big things with is, we're not dealing with just one client pretty much ever, right?
The data you're talking about?
Well, I'm talking about a lot of people are connected to whatever app it is, and they're editing and retrieving different amounts of data, and so you end up dealing with race conditions, who edited first versus, and this guy grabs the data, this guy edits it, and now this person's looking at all the data.
Yeah.
Or, just trying to sync that all up.
So how do you reconcile those differences? How do you keep that stuff in sync? That, hey, this person's looking at some data, but this person then changes it. It's like, well, this person, what they're looking at is wrong now because what's in the database has changed since they've got it. So there's some major problems there. Okay, so just getting and setting remote data, there's some challenges there. What do we actually do to get this data? And we need a solution that allows us to do this kind of orchestration, right? We also need a solution, again, that repeating theme. It needs to be the run server side, right? We might need to do some stuff server side, depending upon our needs, right? So what are some solutions? So we could use, I actually should have reordered these. We could use just XML HTTP request, right? How many people have used that and thought that it was fun and dandy and didn't wind up in callback hell? Anybody? Yeah. So it's a solution that's there, and it's one that's old. We could also just polyfill fetch. Which, how many people are familiar with fetch and what it is? So fetch, for those that didn't raise their hand, because only like 5 of you did, and only half the stack team did.
We weren't paying attention.
So fetch is a native spec for the browser that is a promise-based spec for handling essentially. It's essentially XML HTTP request, but promise-based and has a much cleaner API, much cleaner abstraction over it. And so we could use that. We could polyfill that. It's not necessarily completely supported by all browsers, but we could polyfill it. It's not that huge of a polyfill. We could do WebSockets. Yeah. We could also use something that has a little higher abstraction layer, has a little bigger abstraction over the problem, and of Axios and SuperAgent. Those ones, though, don't necessarily solve the problem perfectly. So we've chosen fetch. So fetch, as I said, it's becoming the standard, right? It's not necessarily supported by all browsers, but it's supported by a great amount of the browsers, right? So we'd have to polyfill it, which isn't that big of a problem. It's also promise-based. So promise-based, that allows us a good way to orchestrate things that are going to be occurring here. Right? It's a really good path to take. Yes?
Do we have to use fetch?
Not necessarily. I would.
So we have options.
Yes, there are options. Also with fetch, there's a server, a node, how'd you describe it, Jared? Isomorphic fetch. It's a little, I guess, polyfill for node.
Called a ponyfill.
A ponyfill? Is that's the name for it? It's a ponyfill for node, so that we can use fetch in node. And so there's that. We're able to then use fetch server side. So we can write the same code and have it run both client side and server side, right? And have the same kind of orchestration and stuff working. So again, we're able to write single code base that runs both places, right? Okay. So we've looked a little bit at the state management problem space, and we've seen how Redux and a few other tools that work alongside Redux are able to solve that problem space really well. Okay, so let's go ahead and talk about managing CSS. So we're not necessarily talking here about actually defining the styles, the different problems that you have with styling things, but more of managing the actual styles that are going to be defined. How do we keep them managed? What are some problems there? Yes? You get style collisions? So like, are you talking about like class name collisions where like you'll...
It could be that, or just things that override in places where you didn't expect.
Right, so you have collision because CSS itself by its nature is global. And so you could have styles that you add here and all of a sudden you've messed up something else some other place that you had no idea. Yeah, multiple inheritance, you're saying. So the huge inheritance structure of CSS, it is global, right? Any style that you add, it's going to add to anything in your entire application that happens to match that style, right?
Having an old CSS file that you don't know in what dark corner of your website is still actually using those rules, so
right.
you can never delete it.
Right. So, I mean, how many people have inherited, like Mike just described, a project that has styles, or maybe you even defined, you've been working on this application, you define these styles. How many people have defined styles where it gets to a point where you're not sure what style belongs to what?
Well, I think it gets even worse than that. We have an app that has this, like old Cubs. I don't even use this. I just straight inline style tag.
Inline.
Right, because then at least I know what I'm affecting.
Right, so you're inlining your styles
Right.
just because
I'm creating a nightmare
you're sick
for
of
the
it.
next guy, and I'm totally okay.
You're just creating a nightmare, he says. Oh, wow. And you just don't even care.
Well, I mean, because
man.
you have, our website,
Ugh.
Cubs has, probably a couple thousand pages, and I can't, trying to figure that out just becomes cumbersome, and I don't have time to do that.
Just being able to determine what things will affect what. If you add something, what is it going to affect? You
Right.
just don't have time to try and figure that out.
Yep.
Yeah. And another big thing is how many people have had their CSS just grow and grow and grow, and you're like, I want to try and shrink this down, but you're like, I can't. I have no idea. If I take this out, what's going to happen? I have no idea. How many people have experienced that in defining their CSS? How many people have actually written CSS that's what's happened? I know I have. I've had projects where that's what's happened, and it's a huge problem, right? So CSS, the problem space gets harder and harder the more your project scales, right? Just the bigger it scales, the bigger the problem gets. It just becomes this huge mess, right? It's almost impossible to keep your CSS dry, to not repeat things throughout your CSS. It's almost impossible to do that, right? It's impossible to know what style is going to affect what things, right? Because it's global, because style itself is global, right? It's hard to keep things organized, right? Okay, so what are some things that we can do? So we've already talked about how we have a monolithic style sheet, right, that has everything, all the styles for the entire application is right here, period. That just doesn't scale, right? We could do inlining like Jason just described, where we just have style tags, inline style tags everywhere that we're going to be doing stuff, right? We could do that. There are some tools out there, some solutions out there for us. So SAS gives us some more intelligent things that we can do. We're able to do some nesting and some variables and things like that help us keep our CSS much more dry, right? And have CSS partials that only affect things, right? And we can use conventions like BEM that help to keep our CSS scoped, right? Keep things scoped so that we know these styles actually belong to these things. And we know with much more confidence what styles affect what things, right? And so there's some other things. So CSS Next is similar to SAS. It has a similar problem space. And CSS modules, which these are what we're actually going to be talking about. So CSS Next. So why it opposed to other things? Well, CSS Next is actually allows you to utilize future CSS syntax. So you're actually writing syntax that's going to become part of the spec and is becoming part of the spec. It doesn't necessarily have full browser support. So it's kind of like using ES6 and how that compiles down so the browsers can understand what it is. It's the same idea, but with CSS, right? And so why would we want to do that? Well, utilizing future syntax as opposed to other things that are not necessarily pointing towards the future standard is a better investment. It's better to invest in your project and in your own knowledge to utilize these technologies. And so because of this, your CSS is going to last the test of time much longer, right? Does that make sense? Any questions there? Okay. CSS modules. Oh man, I'm running out of time. CSS modules. The problem here is scoping, right? So a CSS modules literally, it programmatically goes through and makes your class names that you define unique and matches them to where you're using them. So you essentially get the benefit of BEM, where BEM is is allowing you to scope your class names to what they belong to, but it does it programmatically so that you don't have people that might not follow BEM perfectly and kind of throw things off and kind of break it. Because if you're not following the conventions of BEM perfectly, then you might as well just not be doing it because you're going to have all the same problems. But with CSS modules, it kind of enforces that. It forces this uniqueness to occur. And so you're able to write your CSS more blissfully. And I personally find it quite freeing. You're able to be much more confident in what you're defining and how you're writing your CSS. And it's just great. So we've looked at the problem space of styles and seen how CSS Next and CSS modules is a good problem, or is a good solution there. So let's go ahead and talk about transpiling. So here we're talking about like Babel and that type of thing, right? Kind of spoiler alert there, sorry. So what's the problem space of transpiling? Why do we need to do it? Anybody?
Different browsers have different support levels of JavaScript features.
Yeah, right. So browsers have inconsistencies, right? There's inconsistencies between different browsers. They don't all support the same syntax, the same JavaScript, right? And it's hard to know what features we can use where, right? What can we use in what browsers, right? So what things can we do? Well, we could become very good pals, very, very close with caniuse.com, which tells us here, these are browsers that support these features, and we could get really familiar with, okay, these are the features that are supported, and we'll just strictly use those features, right? And not use anything else. We're not going to branch out into these new features until the support is there, right? We could do that. There's some problems there. We could use other tools, though, that allow us to use future syntax, like Tracer or TypeScript or Babel. And these things allow us to use that future syntax, and it compiles it down into what is supported by browsers, right? So we've chosen Babel. So Babel essentially does all that hard work of trying to figure out what needs what, and how to do it. And it does it for you so that you can just use the fun parts of the language and write that and let the computer just compile it to what is supported. So it actually takes this future code, this future syntax, and compiles it into a format that is compliant to all different browsers, is supported essentially.
You could say that it takes current syntax and transpiles it to old spec.
Right. That's pretty much this. Yeah. So we're actually using current spec syntax and compiling it down into old spec syntax that is supported by what your project needs to be supported. Support the browsers that you need to support.
I think it also lightens your mental load too, because you can write one way and not worry about. The biggest thing for the developer experience is knowing that you just write it a certain way and let something else do the work for you. And if you're going to the browser, you just change the compile target, or if you're going to like Node 6 or something that has more feature, you just change the target, but the way you write code is exactly the same.
Right. So you get to write the code the same way, and essentially let the compiler do all the hard work for you. It determines what to compile it to. Is that? Yep. Okay. So that's one part of our build process. What's the next part? Is actually building our application here. Yes, I do. Okay, so we'll skip ahead a little bit, or we'll speed through this a little bit. So build. What's the problem space here? Well, we need to actually take our assets and build them into our actual bundle, right? We also need to be worried about getting all the things that need what they need. They have dependencies, and we need all of those things to come together, right? Otherwise, we're going to have things that don't work right. And it's difficult to know how we're going to do this, how we're going to build all this together. And what things do we need to do with different types of assets? We've already talked about JavaScript and CSS, and there's some processing that needs to happen to these things in order for them to work right?
Or be optimized.
Or yes, and optimize. Yeah, that's also part of it. So what solutions are there? Well, we could have one giant script file and one giant CSS file. We've already talked about that and determined that's not a very good route. We could have tons of things all over the place, inline stuff. And that doesn't necessarily work very well. And so we know that we need to use something that programmatically creates these things. So there's Grunt, there's Gulp, there's Browserify, there's Webpack. These things all build your assets into what your end application that you send to the client is, right?
Bundler.
Say what?
The bundler.
Yes, it's a bundler. It bundles up your application. All right. So real quickly, a module, how many people don't know what a module is, would like a definition? So a module is just an individual piece of code. In regards to the front end, we're worried about a piece of code that has its own scope, is configurable and composable, right? So Webpack. We've chosen Webpack because it's a much more intelligent bundler. And it is able to more programmatically put together your bundle and analyze the individual assets that have been declared as dependencies and do the correct processing on those types of assets. And so this is a powerful thing. We're able to do more powerful builds than before. It also gives us code splitting, and so that we can load the individual parts that we want on demand, so we can make it so that what we put over the wire is lighter. And it also gives us tree shaking soon. Not quite, but it's coming. Webpack 2, I believe, is where we're going to be getting tree shaking. Okay, so we've looked at the build problem space and seen how Webpack and Babel are resolving that problem space. And here we have our complete picture. We've seen the whole problem space, we've broken it down into individual pieces, and we've seen how each of those problem spaces are solved by certain technologies. And we see how these different technologies are going to be able to work together and become an overall solution for the whole problem space, right? So in summary, a few things that I want to think. Well, one last point I want to try to make is we really feel it's important to try to point to the standard. That we want to be utilizing the future spec or the current spec, and we want to be pointing towards that. And there's 3 pillars of the front end web: HTML, CSS, and JavaScript. We should really be pointing at those and what they are, and understanding them. And we feel that technologies such as Babel, CSS Next, they actually are those are actually allowing you to use that syntax, actually use that future, those pillars. We're looking at the base pillar, the base cornerstone, I guess, of the web, and utilizing those. And React and Redux, we really feel, point you towards utilizing the features of JavaScript in a much more native way. And why do we want to do this? Well, the reason why is because your tools will then eventually be able to be replaced in the future, because we're just utilizing what's already there. We're utilizing what's supported by the web. And so it's a better investment in your project and in your knowledge of the front end. And so to close, we encourage you to utilize the React stack that we have. We really feel that the React stack is a good solution for this problem space. It has all these solutions together working well to solve these problems for you in a way that works. And so, thank you.